Hello. Through this session, we will be discussing the definition and the basic concepts behind prime numbers. Number 1, definition. Any number which is not divisible by any number besides 1 and itself is called a prime number. So, a number not divisible by any number except 1 and itself is a prime number. By definition, 1 is not a prime number, because from here we can definitely say that 1 is not divisible by any other number besides 1 and itself. But still 1 is not a prime number. So, by definition 1 is not a prime number. Number 2, 2 is the least prime number. Also, 2 would be the only even prime number. Besides 2, all other prime numbers, they would be odd, obviously, because if a number is a multiple of 2, it will become composite number. Numbers which are not prime numbers, they are called composite numbers. So, prime and composite. So, 2 is a prime number, 3 is a prime number, 4 can be written as 2 into 2, so 4 is a composite number, 5 would be a prime number, 6 3 into 2, so 6 is a composite number, and so on and so forth. Can we very quickly count the number of prime numbers from 1 to 50? Let us look at the number of prime numbers from 1 to 50. 2, 3, 5, 7, 11 would be a prime number. I will go horizontally, it would be easier. 11, 21 is not a prime number, 31 would be a prime number, 41 would be a prime number. 3, 13, 23, 33 would not be a prime number, 43 will be a prime number. Anything that comes with the row of 5, that would not be a prime number. 7, 17, 27 is not a prime number, 37, 47, 9 is not a prime number, 19, 29, 39 is not a prime number, 49 is again not a prime number. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. There are 15 prime numbers from 1 to 50. Second part, let us extend this idea. Let us look at the number of prime numbers from 51 to 100. 41, 51 is not a prime number, 61, 71, 81 is not a prime number, 91, very common mistake, 91 is again not a prime number, 91 is 13 into 7, 43, 53, 63 is not a prime number, 73, 83 would be a prime number, 93 is not a prime number, 57 is not a prime number, 67, 77, 87, 97 would be a prime number, 59, 69, 79, 89, these would also be prime numbers. So, from 51 to 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there are 10 prime numbers from 51 to 100. So, 1 to 50 there are 15 prime numbers, 51 to 100 there are 10 prime numbers. Also, any two prime numbers which are separated by 2 are called twin primes. So, two prime numbers which are separated by 2 are called twin primes. For example, 3 and 5, these are twin primes. 5 and 7, twin prime. 11, 7 and 11, they are separated by 4, they are not twin primes. 11, 13, twin primes. 13, 17 are not twin primes. 17 to 19, these are again twin primes. 23, 29, 29, 31, these would be twin primes. 31, 37, 41, 43, 41, 43 would again be a twin prime. 59, 61, this is again twin prime. 67, 71, 73, again twin prime. 79, 83, 89, 97. So, these would be the twin primes from 1 to 100. Next, let's look at a general method for checking if a number is a prime number. Usually what we do is, in order to check if a number is a prime number, we try to divide the number by all the numbers from 1 till the number. So let us say if I have to check if 37 is a prime number. It's a very simple example. In order to check if 37 is a prime number, what I will intuitively do is I will check the divisibility of 37 by all the numbers from 1 to 37. I do not have to do it essentially this way. What I can always do is, let us look at what is the square root of 37. The square root of 37 would be 6 point something. If the square root of 37 is 6 point something, I only need to check the divisibility of 37 by numbers, prime numbers from 1 to root n. Because if the number is divisible by a composite number, the composite number can always be broken into prime number, and then it will be divisible by a prime number also, number 1. Number 2, if the number has got two factors a and b, if one of them is less than the square root, the other one will necessarily be greater than the square root, and vice versa. That means that if I have to check the divisibility for 37, I don't need to look at all the numbers. Checking on one side, that will be sufficient to ensure the divisibility of the number. So therefore for 37, I will check by 2, 3 and 5, because it is not divisible by 2, 3 and 5, therefore 37 is a prime number. Similarly, let us say if I have to check if 191 is a prime number. 14 square is 196, so I will go till 14. Till 14, the prime numbers would be 2, 3, 5, 7 and 11, and obviously yes, 13 also. So 2, it is not divisible, 3, it is not divisible, 5 definitely not divisible, 7 again it is not divisible, 11 it is not divisible, 13 also it is not divisible. So therefore 191 would be a prime number. So that's about a general method for checking if a number is a prime number. A similar concept, or rather a term that we use with regard to prime numbers, that is co-primes. Co-primes are only related to prime numbers in so far as they are called co-primes. Otherwise, co-primes are not necessarily prime numbers or have anything to do with prime numbers. Two numbers a comma b, they are co-prime if they do not have any common factors. So two numbers which do not have any common factor except one, obviously, are called co-primes. So for example, 2 and 5, because they do not have any common factor, they would be co-primes. 5 and 11 would again be co-primes. You would be surprised, probably, but if 2, 5 are co-primes, 5, 11 are co-primes, 4 and 9, they are also co-primes. This is when 4 is not a prime number, 9 is not a prime number, but it's still two numbers which are not primes, they can very comfortably be co-primes. So therefore for two numbers to be co-prime, they need not necessarily be prime numbers. A couple of very important concepts with regard to co-primes. Number one is co-prime with every other number. Number 2, the two numbers that I am looking at need not be prime, and which is why I said that co-primes are related to primes only in so much as they share the term prime, otherwise they have nothing to do with prime numbers. Number 3, two consecutive odd numbers are co-prime, sorry. Similarly, two consecutive natural numbers they are also co-prime. If I take 2, 3, 3, 4, 5, 6, 7, 8, 15, 16, 91, 92, all the whenever I take two consecutive natural numbers, they would also be co-prime. On the contrary, two consecutive even numbers are not co-prime. One last concept that we need to understand with regard to prime numbers is the general form for prime numbers. As we understand, the general form for odd numbers is 2k plus 1, where k is equal to 0 or greater than 0. So, odd numbers are of the form 2k plus 1, even numbers are of the form 2k. Alternately, any number which is of the form 2k plus 1 would be an odd number, any number which is of the form 2k would be an even number. As far as general prime numbers are concerned, as we will see, any prime number greater than 3 can be written in the form 6k plus minus 1. So, any prime number greater than 3 can be written in the form 6k plus minus 1. Let us understand why. Imagine p is a prime number. I am looking at three consecutive numbers p, p minus 1 and p plus 1. If p is a prime number and I am looking at three consecutive numbers, I also understand that if I look at any two consecutive numbers, one of them has to be divisible by 2. Or in general, if I look at any n consecutive numbers, at least one of them has to be divisible by n. So, if I look at two consecutive numbers, one of them is divisible by 2. If I look at three consecutive numbers, one of them is divisible by 3. If I look at four consecutive numbers, one of them is divisible by 4, and so on and so forth. So, here one of these two numbers has to be divisible by 2. Because p is a prime number, p is not divisible by 2. So, necessarily this number is divisible by 2. By same logic, this number is also divisible by 2. If I look at three consecutive numbers, one of them has to be divisible by 3 also. Because one of them has to be divisible by 3, either this number is divisible by 3 or this number is divisible by 3. In case this number is divisible by 3, then this number put together is divisible by 6. And if it is divisible by 6, I can say p minus 1 is equal to 6k. And if p minus 1 is equal to 6k, p is equal to 6k plus 1. On the other side, if this and this, if p plus 1 is divisible by both 2 and 3, p plus 1 is equal to 6k, which means that p is equal to 6k minus 1. So, therefore, in general, one of these two will always be true. So, therefore, every prime number will be of the form 6k plus minus 1. For example, 5 is 6 minus 1, 7 is 6 plus 1, 11 is 6 into 2 minus 1, 13 is 6 into 2 plus 1, 17 is 6 into 3 minus 1, 19 is 6 into 3 plus 1, 23 is 6 into 4 minus 1, 25, interestingly, is not a prime number. Even though it is a number in the form 6k plus 1, it is not a prime number. What this means is every prime number is of the form 6k plus 1. Does not mean that every number in the form 6k plus minus 1 is a prime number. So, every prime number is of the form 6k plus minus 1. Not every number of the form 6k plus minus 1 is a prime number. So, we will find a lot of such numbers which are of the form 6k plus minus 1, but they are not prime numbers. As a matter of fact, the greatest prime number is unknown. So, that was about the basics on prime numbers. Thank you.